Hi everyone. Okay, today I'm going to go through the last part of LHopital's rule, part 3. Okay, so we'll be applying LHopital's rule to find limits that give us limits question that give us indeterminate form of another type that involve powers. Okay, so we introduce the indeterminate form first, then from there we give the steps that involve to find the limits, which eventually we can use LHopital's rule. So first we say if limit x approaches to a fx gx. Okay, so there are powers involved, so will be the same as limit x approaches to a fx square bracket power limit x approaches to a and gx. So if we applying the rule of limits, and we find that we evaluate this limit first before we decide what to do. If it gives us a value, then we no need to use LHopital's rule. But if it gives us some indeterminate form, which could be like that, 0 power 0 or 1 power plus minus infinity, or plus minus infinity to the power of 0. So if any of these three forms of indeterminate, okay, is obtained, these are the indeterminate form that involve power. So if any of these indeterminate forms is obtained, then there's we still can apply LHopital's rule, but not immediately. Okay, we have to do some manipulations to simplify this indeterminate form to the indeterminate form that is required by your LHopital's rule. Okay, so that's the crux of this type of question. So what happens if this is true? Then we say then we have to follow the following steps. So by the following steps, we still can apply LHopital's rule. After the following steps, right? Okay, after the following steps. So basically, before you can apply LHopital's rule, so your indeterminate form must be 0 over 0 or plus minus infinity over plus minus infinity. So these are the only acceptable indeterminate form before you can use LHopital's rule. Okay, so the first step, of course, here we're going to learn how to convert to this form. So what's the first step? First step is to convert. Okay, your 0 power 0 or 1 power plus minus infinity or plus minus infinity bracket 0. Okay, convert this to what? To 0 times plus minus infinity. So we have to convert to this form. Okay, first by using how? By using what? Logarithm manipulations. Okay, so that is your first step. Now, second step. So after you obtain this form, so you already obtained this form. After that, you're going to convert this form to your 0 over 0 or plus minus infinity over infinity, plus minus infinity. So say convert zero times plus minus infinity to 0 over 0 or plus minus infinity to plus minus infinity. How? By using algebraic manipulation, right? Okay, by using algebraic manipulations. Okay, of course, the last step after you do all this, the last step we can apply. That means we can now apply LHopital rule. Okay. So okay, now I will show you the first example in the slide to illustrate the ideas behind it. Okay. So this is the steps. These are the steps and also the condition to use these steps. Okay, here is our first example from the slide, example 8. So you have to find the limit of x approaches to 0 plus x power x. So of course, if you do a checking, so when you do a checking, you will find that this, when x is 0, okay, you do a checking here. So x is 0, you get 0 power 0, which is, okay, this is your checking. Which is your indeterminate form, right? Indeterminate form. So now you have to use the first step. What's the first step? Logarithm manipulation. That's the first step. So we do logarithm manipulation. That means first we let y equals to x power x. Then you log both sides. And still long y, you bring down the power, and then y will be, you bring long to the right side, x power x. So you observe that these two are the same, right? Okay, why are they the same? Because this is y, this is also y, so it means they are the same. Okay, so it means we can safely say that limit x approaches to 0 plus x to the power x, correct, will be the same as the limit x approaches 0 plus ex power log x, ex times log x, e to the power of x times log x. So now we still have not So we are here, but we haven't reached 0 times infinity, right? So we're going to reach soon. So we say that so b equals to e, right, power limit. Now the limit only affect x, so x is the power of e, so the limit can actually concentrate on terms that involve x only. Okay, so we'll be like that. So this is a very important thing. So the limit will reduce to this form. So therefore we say, so here I'll continue the right side. So here we just need to find the limit. So therefore x ln x, correct? We need to find this one. So before that we can say this is equation 1, right? This is, you can say this is your equation 1. Okay, so after you find limit of x ln x, then you sub back into equation 1. Now to find, so again you do a checking. So checking, checking means you put the x value into the expression inside the limit and find, is it 0 over 0 or 0 times infinity, or that, no? Or that possible cases. So the checking say that is 0 ln 0, right? Now ln 0 is negative infinity. Okay, so we have already converted, no? So we have done this. So that means from here to here we convert, no? So we have convert 0 to 0, convert to, so converted. Okay, 0 power 0 to 0 times infinity. So we have converted successfully. Okay. So what's the next step now? No, so since it's true, then we need to convert this to 0. So we need to, next step after that, we need to convert this to your 0 over 0 or plus infinity to over plus infinity, right? So that is our objective here. So you must use algebraic manipulation to produce a fraction. So you say limit x power 0, so ln x over 1 over x. So this is our fraction. Correct. Okay, then before you do, you can do checking. No? So you do checking. Do we get, what do we get? We get ln 0 over 1 over 0. Now ln 0 is negative infinity. 1 over 0, so correct. We have converted. So this is where we are, so this is the path. So successful. Okay, done. So since we are successful, now we can use LHopital Rule. So equal. Now apply LHopital Rule. Okay, so after you use the LHopital Rule, you get limit x power x to x approaches 0 plus, we get minus x. So of course this one will give us 0. Right. So now you say this is 2. So what do we get here? So we say therefore which is this, right? Which is this one is actually the power, right? So it is sub 2 into 1. So therefore we say limit x approaches 0 plus x power x e power 0, right? Which is 1. Okay, so this gives us the limit, okay, for this question. So next I'll go to example 9, still which is the next example in your slide. So this is example 9. So first we do write down the question and do a checking. Right, so checking. So we get 1 over 0 power 0, so infinity to the power 0. So of course it's a indeterminate form that involves power, right? Power 0. So you have to use the 3 steps. So let y equals to x power z sine x. So ln y ln 1 over x sine x. So we bring down the power sine x, bracket ln 1 over x. Now 1 over x is sine x ln. Now 1 over x is x to the power of minus 1, right? Then you can bring down the power, so we bring minus sine x times ln x. Okay. So y must be e to the power of minus sine x times ln x. So that's our first step. Okay. So if you want to do some shortcut, you no need to think about put the limit. You just say sub 0 sine 0 ln 0, right? Sub x equals 0. So this gives 0, so it's negative infinity. So we are done, right? Okay. So you just need to focus on minus sine x ln x, right? So how to do? So we have to simplify. So of course limit. So these two are the same. X approaches 0 plus 1 over x sine x must be limit x 0 plus e minus sine x ln x. Okay. So that is that's the important thing. So after this step, when we do a checking already, so we have to use algebraic manipulation, right, to convert to fx over gx. So we just, but before that we can say, okay, so we say is equals to e limit x to the power of 0 plus sine x minus ln x, okay, times 0. So we just focus on this limit now. What is the value of this limit? Then once we found the answer, we sub into this. So we call this equation 1. So we write down the limit. So negative sign we can put outside. Now we convert to fraction, right? So limit ln x. So it's better to retain ln as a numerator. Okay, the other one as a denominator. So 1 over sin x. So checking. So when we check, so put ln 0 over 1 over sine 0. So this one will give us infinity, negative infinity over infinity. Right. So okay, can. Now we can use LHopital Rule. So we just say equals to negative limit prime over, now sine x is actually cosecant x, right? 1 over sine x is cosecant x. Okay, so use our formula, 1 over x over, now cosecant you differentiate will become minus cosecant times cotangent x. Okay, so now we have to simplify to simpler algebra, trigo. Now negative and negative gone, so this negative sign gone. So cosecant x is 1 over sine x. Cotangent is cosine x over sine x. So we simplified, we get limit x approaches to 0 plus, and then sine square x, sine x over x, and sine x over cosine x. Right, you group these two together. So you group this, okay, you get this sine x over. Now you can use our limit, right? X equal to 0 plus sine x over x. Bracket. Now this is tangent, right? So limit so don't forget sine over cosine is tangent. So this one is 1, right? Our previous chapter. So times 0. So it'll be 0. Right. So now we sub the value 0 back to the question. So it's 2. So now we say sub 2 into 1, right? So we say therefore limit x approaches to 0 plus 1 over x power sine x must be equals to limit e power 0, right? Which is 1. Okay, so this is our solution for this question. So I hope you get the gist of it. Okay. So I hope you can get the gist of it and able to remember and apply the technique. Okay, I will go to example 10 now. Okay, so this is example 10, which is our last example for LHopital Rule. So first we do checking, or write down the question first. So we check, right? So you get 1 plus 1 over infinity power infinity. So of course you get 1 power infinity, which is the indeterminate form for this type of question. So similarly, same thing as before, so we let y equals to 1 plus 1 over x power x, right? So ln y 1 plus 1 over x power x. So bring down the power, ln y. So therefore y will be e power x ln 1 plus 1 over x. So now the limit, so we can go into the limit infinity 1 plus 1 over x power x must be limit x approaches to infinity for the e x ln 1 plus 1 over x. So you affect the, you just limit the powers, right? Because the power is the one that contains x. So e, similar to what we did just now. Okay. So we just concentrate on finding the limit for this now, right? So we go, so we say this is equation 1, remember? So now we are ready to do our next step. So we say limit so we do checking, right? Checking. So infinity ln 1 plus 1 over infinity. So it means infinity ln 1 over infinity is 0, so 1. Ln 1 is 0. So we got the form. So you express as fx over gx. So ln we keep at the numerator. We bring the x down, so we have 1 over x. Okay. So now how? LHopital Rule, right? So limit. So now you can use LHopital Rule. Square bracket prime over 1 over x prime. So you differentiate this, you differentiate inside, you get, you differentiate ln, you get 1 plus 1 over x. Then you differentiate inside, you get 1 over x prime, right? Over 1 over x prime. So they are the same, so you can cancel off. Okay. So eventually you get equals to limit x approaches to infinity 1 plus 1 over x. So of course this one will become limit x approaches to infinity. So the infinity you can go into the x 1 plus 1 over limit x approaches to infinity. Okay, you can go into the 1 over x. So obviously it's 1 plus 0, right? So it's 1. So now you sub this value, subdue into 1, right? So 2 is the value for the power of the exponential. So eventually, so therefore limit x infinity 1 plus 1 over x to the power of infinity must be equals to e to the power of 1, which is e. Okay, so that is the answer for this limit question. Okay, so I finally finished LHopital's rule. So the next topic or the next video that I'll be showing or teaching will be on improper integration. Okay, so I hope you all understand now and try the tutorial questions as much as possible. So I hope I can discuss them with you when I see you again in week 13. Okay, thank you very much for your attention.